Hello, stormwater designers. Welcome back to Clear Creek Solutions hydrology education videos. We're continuing our minimum requirement series, and we're on minimum requirement number 6, and that is runoff treatment. And so now we're going to get into this one. It says here that projects shall employ runoff treatment BMPs in accordance with the following thresholds, standards, and requirements to remove pollutants from stormwater runoff. So we'll talk about the TDA thresholds. Each TDA within a project that requires minimum requirement number 6 must be reviewed to determine if runoff treatment BMPs are required for the TDA to be in compliance with minimum requirement number 6. Note that it is possible for a project that requires minimum requirement number 6 with multiple TDAs to not need runoff treatment BMPs in one or more of the individual TDAs. If a TDA does not trigger the TDA threshold for runoff treatment BMPs, then the designer must document the areas within the TDA used to determine that the TDA threshold was not met. This documentation will demonstrate compliance with minimum requirement number 6 for the TDA. When assessing a TDA against the following thresholds, only consider the type of surfaces, e.g. new hard surfaces, replaced hard surfaces, converted vegetation areas that are subject to minimum requirement number 6 per the project thresholds in 1-33, applicability of the minimum requirements. So the following TDAs require construction of runoff treatment BMPs. If a TDA meets any of the following thresholds, runoff treatment BMPs are required. The project proponent must demonstrate that the TDA does not meet either of the following thresholds for runoff treatment BMPs to not be required for that TDA. TDAs that have a total of 5,000 square feet or more of pollution generating hard surfaces, or TDAs that have a total of 3/4 of an acre or more of pollution generating pervious surfaces, not including permeable pavements, and from which there will be a surface discharge in a natural or man-made conveyance system from the site. So runoff treatment sizing, size runoff treatment BMPs to treat the water quality design flow rate or water quality design storm volume as detailed in 3-26, sizing your runoff treatment BMPs. We can use wwhm 2012 for this, and we're going to do this at the end. We're actually going to do a little bit of modeling there. We also have a free guide on how to model bioretention facilities in 5 easy steps. You can find that guide in the description box if you want to learn how to do that in wwhm 2012, which is a free software that can be downloaded from our website and can be used to meet minimum requirement number 6 for runoff treatment BMP sizing. So runoff treatment BMPs shall be selected in accordance with the process identified in 3-12, choosing your runoff treatment BMPs, designed in accordance with the design criteria in volume 5, and maintained in accordance with the maintenance criteria in volume 5. Additional requirements: the direct or indirect discharge of untreated stormwater from pollution generating hard surfaces to groundwater must not be authorized by the local government except for infiltration or dispersion of runoff through LID BMPs per the list approach that we went over. The direct discharge of untreated stormwater from pollution generating hard surfaces to groundwater is prohibited except for infiltration or dispersion of runoff through LID BMPs per the list approach. The purpose of runoff treatment is to reduce pollutant loads and concentrations in stormwater runoff using physical, biological, and chemical removal mechanisms so that beneficial uses of receiving water are maintained and, where applicable, restored. When site conditions are appropriate, infiltration can potentially be the most effective BMP for runoff treatment. Supplemental guidelines C3-12, choosing your runoff treatment BMPs for determining the appropriate runoff treatment performance goal for the site, and a list of BMPs that may be used to meet the performance goal using the presumptive approach. See Volume 5 for detailed guidance on design and maintenance of runoff treatment BMPs. An adopted and implemented basin plan, or total maximum daily TMDL, also known as the Water Cleanup Plan, may be used to develop runoff treatment requirements that are tailored to a specific basin. However, runoff treatment requirements shall meet, at a minimum, the basic treatment performance goals as detailed in 3-12, choosing your runoff treatment BMPs. Runoff from surfaces that are not pollution generating do not need to be treated and may bypass the runoff treatment BMPs if it is not mingled with runoff from pollution generating surfaces. Drainage from areas and native vegetation should not be mixed with untreated runoff from streets and driveways if possible. It is best to infiltrate or disperse this relatively clean runoff to maximize recharge to shallow groundwater, wetlands, and streams. So revising MR6 through a basin plan. Basin plans, see Appendix 1B, basin plans can develop different requirements and performance standards than those detailed above to reduce pollutant concentrations or loads based on an evaluation of the beneficial uses to be protected within or downstream of the basin. Consideration must be given to the anti-degradation provisions of the Clean Water Act and implementing state water quality standards. The evaluation should include an analysis of existing and future conditions. Basin-specific requirements and performance standards can be developed based on the evaluation of pollutant loads and modeling of receiving water conditions. Basic treatment, as described in 3-12, choosing your runoff BMPs, is a minimum standard that must be applied regardless of the quality of the receiving waters. Additional levels of runoff treatment beyond basic treatment may be justified in order to control the impacts of future development. Runoff treatment requirements and performance standards developed from a basin plan should apply to the individual development sites within the basin. Regional runoff treatment BMPs can be considered an acceptable substitute for on-site runoff treatment BMPs if they can meet the runoff treatment requirements and performance standards identified in the basin plan. A limitation to the use of regional runoff treatment BMPs is that the conveyances used to transport the stormwater to the regional BMP must not include waters of the state that have existing or attainable beneficial uses other than drainage. The above text describes how basin plans can influence runoff treatment requirements and performance standards for new and redevelopment. Basin plans can also be used to identify structural retrofit runoff treatment requirements for reducing the effects of existing development on the aquatic resources. So now we're going to get into modeling here. So this is wwhm 2012, and I have a sample project. You can do a few things with bioretention. I have a basin here with 1 acre of sea forest flat in our pre-developed condition. I'm going to run that scenario here. Again, we're in the wwhm 2012 model, which is primarily used for modeling these circumstances here and can model the bioretention element. So we're generating our pre-developed runoff here in the basin. If we go to mitigated, we have a basin which has 1 acre of roads. This is just an example project here. And now we added our bioretention facility. And so we can see we can size it for water quality, or we could actually size the facility for meeting the flow duration standards. So we have a couple different options there. In this case, I'm going to size the facility for water quality. We would click size for water quality after connecting it to the point of compliance here. And then the model can actually do the sizing for you, size for water quality, and it's going to size this facility to meet that water quality standard as we discussed before. So that's an example of what wwhm can achieve with your facility, and it'll size it to meet that standard. So I'll show up when this is done sizing, and we can look over the final dimensions. Okay, so our sizing is complete. It meets that 91% filtered standard. It's a 23 by 23 facility with a 4 feet of effective total depth. So that is our bioretention facility. That's how we model it in the model. Like I said, that free guide is in the description box down below. And that completes our look at minimum requirement number 6, and we're going to move into minimum requirement number 7 in the next video. So thank you so much for watching, and we'll see you guys next time.